Hello everyone, in this video we will be learning about de Moivre's theorem, which is very useful when we are solving complex number. Let's see how it is more useful. So first of all, the steps which we are following when we are solving this using this de Moivre's theorems, I have listed over here. First of all, we will check whether the given number in the Cartesian form. Then we will finding theta, which is nothing but the argument we call it, and modulus, which we call it as r. We have already discussed about the formula for theta and modulus also. Modulus, we take the square root of x square of x square plus y square, and the next thing is we will write the given complex number in polar form, and then we will apply the de Moivre's theorem. So what is this theorem says? This is it's a statement, or how in the form, mathematical form, this is how we write it: cos theta plus I sin theta raised to power n, which is equal to cos n theta plus I sin n theta. Simply we write this power in front of the angle of cos and sin. This whatever n is, we are writing in front of cos angle, which is becoming cos n theta, and in front of sin angle, which is becoming sin n theta. So it's pretty simple to remember also. We will solve one question on de Moivre's theorem, so it will be clear how to apply it. Here the given question is cos theta plus I sin theta raised to power 4 upon sin theta plus I cos theta raised to power 5, and what we have to prove is it gives equal to sin 9 theta minus I cos 9 theta. So left hand side, first of all we will start with left hand side. So now if you look here, its numerator is given in the form of cos theta plus I sin theta. This is what we, in order to apply de Moivre's theorem, the complex number we want in that format. But if you look at the denominator, it's something like sin and cos are interchanged, like we have it in form of sin theta plus I cos theta. So we want it cos theta plus I sin theta. If you remember, this is what the statement it is of de Moivre's, cos theta plus I sin theta. This is how the complex number should be there. In that case only we can apply it, and we can write it cos n theta plus I sin n theta. Whereas this denominator is not in that form, it is exactly opposite way it is. Here we want cos instead of sin, and here we want sin instead of cos. So first of all we have to focus on that कि हम उसको change कैसे करेंगे, मतलब how we will get in that desired form. तो sin के बदले cos हमें लाना है, तो हमें पता है relationship. So if I will write cos pi by 2 minus theta, तो उसकी भी value sin theta ही होती है, and instead of cos theta what we can write it sin 90 minus theta or sin pi by 2 minus theta. So I just simply replaced this sin theta and cos theta by using that formula. So यहाँ पे मैंने सिर्फ चेंज किया है, instead of sin theta I wrote cos pi by 2 minus theta, और cos theta के बदले मैंने लिखा है sin pi by 2 minus theta. क्यों किया है? क्योंकि because I want in that form cos theta plus I sin theta, उस फॉर्म में मुझे चाहिए, क्योंकि मुझे de Moivre's theorem उसको अप्लाई करना है to solve those given question. So now after that we have just simplified it. This whole numerator I wrote it in the negative power form. So instead of writing in the fractional form, I took it in the numerator, और ये जैसे भी numerator में मैंने लिया है, ये 5 के बदले -5 हो चुका है, because so now it looks in the format something like जहाँ पे मैं de Moivre's theorem लगा सकती हूँ. So now here if you see here the first इस ये जो पहला वाला bracket है, the whole bracket has power 4, so I have applied de Moivre's theorem over here. तो ये power जैसी है वो angle के सामने आ जाएगी. So it became like cos 4 theta plus I sin 4 theta after applying de Moivre's theorem. Similarly for this bracket also I will be applying de Moivre's theorem. So जो ये -5 जो power है वो यहाँ पे थीटा एंगल के पहले आ जाएगी. सो -5 यहाँ पे और यहाँ पे आ जाएगा. बिफोर एंगल कॉस एंड साइन एंगल. सो यहाँ पे आ गया cos माइनस फाइव इंटू पाई बाई टू माइनस थीटा and I sin minus phi यहाँ पे before angle we wrote it. So this is how we got it now. After this we have just simplified this bracket, first bracket as it is. Second bracket में मैंने ये minus phi जो outside है उसको angle के साथ multiply किया हुआ है. So ये minus phi minus theta के साथ multiplying it become plus phi theta, and this minus phi into pi by 2 it become minus phi by 2, 5 pi by 2. Simply I have done the multiplication with that minus phi with the angle. यहाँ पे भी same way I have multiplied it over here. So this is something which I will get it. After this we have to see how we can simplify this equation. So I am going to use one formula here. जो formula है ये यहाँ पे है, I have put it over here. तो ये फॉर्मूला क्या कहता है कि इफ़ यू हैव टर्म्स लाइक दिस इन द प्रोडक्ट फॉर्म लाइक cos थीटा प्लस आई साइन थीटा इन वन ब्रैकेट, अगेन cos थीटा 2 प्लस आई साइन थीटा 2, एंड सिमिलरली इफ़ यू गो ऑन एडिंग द मोर ब्रैकेट्स ऑल्सो लाइक cos थीटा 3 प्लस आई साइन थीटा 3 एंड सो ऑन. अगर ऐसे आते हैं प्रोडक्ट फॉर्म में ये सारे कॉम्प्लेक्स नंबर, तो हम क्या कह सकते हैं उसको, वी कैन जस्ट सिंपली ऐड द एंगल्स लाइक cos and give it put it them with cos, and we can put them with the sin also, like जैसे कि यहाँ पे सारे एंगल जो थीटा 1 थीटा 2 जो भी है वो cos के साथ लिख दे along with addition sign प्लस आई साइन थीटा 1 थीटा 2. अगर हम और भी थीटा 3 थीटा 4 लेते हैं तो वैसे भी हम इसके साथ ऐड करते जाएंगे लाइक थीटा 3 थीटा 4 समथिंग लाइक दैट. सो दिस इज़ द फॉर्मूला which you have to keep it in mind whenever we come across the multiplication of different complex numbers. So we can directly write their product as this by using it. So now I have for reference I have written this equation from the previous slide जो हमें यहाँ पे मिला हुआ था. Very last we have received this one and we have to simplify it by using that formula. So I have written it over there also for your understanding. यहाँ पे मैंने ये फॉर्मूला को वेरी टॉप में मैंने लिखा हुआ है. तो यहाँ पे हम इस फॉर्मूले को यूज़ करके वी विल सिंप्लीफाई इट हियर. तो यहाँ पे हमारा थीटा 1 जो है ये 4 थीटा है हमारा थीटा 1, और हमारा थीटा 2 जो है ये है दिस वन 5 थीटा माइनस 5 पाई बाई 2. दिस इज़ आवर थीटा 2. So what we have to do it, we have to just add theta 1 theta 2, write it with the cos. So simply if we add theta 1 plus theta 2 क्या आ जाएगा 9 theta minus 5 pi by 2 जो मैंने यहाँ पे cos के साथ लिख दिया. Similarly with sin term also we will be writing this angle, addition of this angle. So 9 theta minus 5 by 2 along with sin also I have written over here. Now उसके बाद जो हम करेंगे इसको simplify करेंगे. We know that cos of minus theta is equal to cos theta, and sin of minus theta is equal to minus sin theta. We will be just using this relation, and we can write it like cos 5 by 2 minus 9 theta, and minus because as we say that sin of minus theta is equal to minus sin theta. So that's why the note here this sign has been changed, because sin of minus theta will be minus sin theta. So that's the reason. Now simply what we have done it here, 5 pi by 2 I have split it in such a way that I should able to write some value in terms of angles like 5 pi by 2 मैंने यहाँ पे भी split किया है like 2 pi plus 5 by 2 if you add them ultimately it will be giving 5 pi by 2. So I have split that in such a way that I should be able to write some value. So now we know that 2 pi के साथ अगर हमें एंगल ऐड करती हूँ तो then I will get the same angle. cos 2 pi plus theta is equal to cos theta. जैसे कि यहाँ पे मैं लिखूँ अगर cos 2 pi plus theta is equal to cos theta. Similarly sin 2 pi plus theta is equal to sin theta. So that's what I have used it here. ये 2 पाई के साथ कुछ भी एंगल अगर हम ऐड करते हैं तो सेम एंगल वी विल बी गेटिंग. सो 2 पाई प्लस थीटा, ये पूरा मैंने थीटा कंसीडर कर लिया है. सो देन आई विल गेट इट कॉस थीटा. ये पूरा एंगल मैंने थीटा कंसीडर कर चुकी है. 2 पाई प्लस थीटा, इट विल बिकम sin theta. So this is what I got it here. Now if you will see here, which will we know the formula, cos pi by 2 minus theta is nothing but sin theta, and sin pi by 2 minus theta is equal to cos theta. So by using that formula we have written here, instead of for this one cos pi by 2 minus theta is equal to 9 sin 9 theta, क्योंकि यहाँ पे थीटा की वैल्यू 9 थीटा है, यहाँ पे थीटा की वैल्यू 9 थीटा है. So I got this cos 9 theta, and this is what they ask us to prove it. That's given in the question. We have to show that given, if you look here, this was our RHS of the given question. They ask us to prove it, and by using the de Moivre's theorems, we have simplified this question and came to the final step of RHS. This is how we can use the de Moivre's theorem when the given question or given complex number has been having some powers, like higher powers like 4, 5 or some higher powers other than square. So it becomes more useful for that. So that's the reason de Moivre's theorem is quite useful while solving the complex number. Thank you.